So we were talking about these planes that we've got here. And the one thing that I wanted to think about was this one that we've got. We've decided that this one was a prism because the determinant was 0. When we put it on our calculator, we saw that there were no solutions. And we can also tell that none of these planes are parallel to each other. So we know the answer is a prism, but the part 3 says use algebra to see if they're consistent or inconsistent. So we're going to have a look now at using algebra to show whether these 3 equations are consistent or inconsistent. Well, we know from our calculator they are inconsistent. And I'm going to show you how we can actually show the examiner, or how you can prove to yourself that they are inconsistent. Are there any equations that seem to share common coefficients? Because they're often a good starting point. Okay, so I'm going to have a look. If I call this one equation 1, equation 2, and equation 3, I'm going to use equation 1 and 3 because they have a matching x coefficient. I'm going to use equation 1 and 3 to eliminate x. Because if I can eliminate x from that, that's a good starting point, right? So I've got x minus 2y minus 11z equals minus 2. And I've got x plus 3y minus 2z is equal to minus 11. What do I do? Subtract, add? Okay, so if I do this one, take away this one, I get minus 2 minus 3, which is minus 5y. Obviously, they go. Minus 11 minus minus 2, minus 9z. Minus 2 minus minus 11. That's 9. Okay, so here is one of my equations. I've used number 1 and number 3 to come up with this thing that I have here. I'm now going to use equation 1 and 2 to eliminate x. If I wanted to, I could have done 2 and 3. I just have to use something that's not that again. So I'm going to do, number 1 is this. What should I do to number 1? Okay, so I'm going to do number 1, and I'm going to times it by 2. So I get 2x minus 2y. Thank you. 2x minus 4y minus 22z is equal to minus 4. And equation 2 is 2x plus 11y plus 5z equals 11. And I'm going to subtract them. So I get minus 4y minus 11y minus 15y minus 22z minus 5z minus 27z. And then I get, pardon? Minus 15 that we've got over here. Now, they look sort of similar to each other, don't they? So if I then take this one and I divide everything by 3, I get minus 5y minus 9z equals minus 15.
Minus 3.
Oh, what is wrong with my brain today? I get minus 3. I get minus 5. Do we definitely get minus 5? Are we agreed on that? So, but I've said minus 5y minus 9z is 9. But now I'm saying minus 5y minus 9z is minus 5. So it's inconsistent because this thing here is telling me that it's 9, but I'm doing it in a different way, and it's telling me that it's minus 5. So, but minus 5y minus 9z is equal to minus 9 when we used 1 and 3. So, system is inconsistent. This is the system up here, yeah? No planes are parallel. So, a prism, okay? This algebraic idea of consistency or inconsistency, just before you finish up, what would need to be different about this second equation if I was showing consistency? It would be equal to 9, okay?
Or if they were like a multiple.
Yeah, or if this thing was equal to 27. You'd have to show that they're the same. No, because these aren't representing planes anymore. These are this is like the combination of the two things together, okay? These are not planes. These are the result of combining two things together. It's a bit like in regular maths when you combine like two equations and then you get another equation that you solve. It's the same thing as that. Exactly. So for your homework, you're going to do those that we've got here, and you won't be able to fit it on this page. So I'd like you to do it all separately, and you can call them like the red one, purple one. Oh, you won't call them that because you've got it black and white. But number them 1, 2, 3, 4, 5, 6, and we'll do that for the start of the next lesson. I want you to show with algebra for all of them whether they can, even if you know that they're in a plane, I need you to practice consistent or inconsistent, okay?